So I'm working on this project where I'm trying to develop a system that will make my rockets go vertical during flight instead of off at some angle. The idea is to try to make them go higher, but also so that they'll stay within the wavered radius and I don't have to walk so far to pick them up. So this system is going to be based on the use of some canard fins that will be located near the nose cone. This is just an example of one of them I put together, and they'll sit on top of the servo like that, and then the fin is what'll project out the side of the airframe. So everything that's required in the system, I mean, this is it. Basically what I've got here is a battery, and then I've got a digital servo, and then I've got a Guardian autopilot, and then I have a Raven altimeter that I've integrated into the system. So the battery, I've basically got it providing power in parallel to the Raven, the servo, and the Guardian. In a lot of setups, the power for the servo would come through the Guardian, but in this case I'm using 4 digital servos, and I'm not sure that the Guardian can handle that much, potentially the amount of power that might be required from the digital servos, so I've got them wired to the battery separately. The digital servos, I'll have 4 of those things, and they're really nice because you can set the center point on them to get the canards lined, and then you can set the endpoints of the travel, which basically is probably the easiest way in this system to set the gain. And the digital servos also have a fail-safe position, so that if there's no signal coming from the, if there's no signal coming to the servo, it'll basically go to a preset position, and that's convenient for what I'm doing with this system. The heart of this thing is this Guardian autopilot, and it's really designed to use with RC aircraft. And there's several different ways that you can use this thing. Ordinarily, you'd have your RC radio plug-in, receiver plug into this thing, and if you let go of the sticks on your transmitter, the Guardian will sense the neutral signal, and basically it'll control the elevator and the ailerons to give you level flight. So if you get in trouble flying your airplane, you just let go of the sticks and it goes level. So that's a pretty interesting feature. So that's the way that I'm initially going to be using this thing. This is a 6-degree freedom device. It's got gyros and accelerometers, so it knows where it is. So in theory, in your plane, if you were to see roll or yaw that way, it would control the elevators and the ailerons to keep level flight. And so I'm going to be using those 2 capabilities. I'm not going to attempt to control roll around the axis of the rocket, but there actually is a configuration where you could do that as well. I thought I would have to provide either a RC receiver or a pulse width PWM generator in order to sort of take the place of the RC receiver. As it turns out, you don't even need to do that. The Guardian will send out a center pulse and basically control without any inputs to it at all. So the signal wire from the Guardian would normally go to the servo and control the servo movements. I've changed this up a little bit, and so what I've got is I got the signal wire coming over to this board, and then from there over to the servo. And what I'm attempting to do on here is to allow the vertical system to be turned on and off based on the flight events as determined by the Raven. So one of the things that concerns me about this system is I'm not sure what the gyros are going to do under heavy motor acceleration. I know that the gyros are going to drift around a little bit, and and it may be a good thing not to have the system in operation during that time. So I could, for example, set up the Raven to provide a signal after, a few seconds after liftoff, or I could set it up to only control when the acceleration was below a certain level. There's some options there. So the way that this works is that the output on the Raven goes into the bottoms of 3 solid-state relays that I've got mounted on this board. The signal wire then coming from the Guardian then goes through the other side of the solid-state relay, so that when the Raven fires, it'll basically turn on the solid-state relays and allow the PWM signal to go to the servo. So I don't know if that's going to actually be necessary, but I'm thinking it probably will, so I'm going to build it into the first system here. So let me go ahead and turn this thing on. Now, one thing, the way I've got this servo set up, the popsicle stick actually represents sort of level flight, but I've got the fail-safe actually off at an angle, so you can just see that when the system turns on, that the servo will go over to its fail-safe position, wherever that is, and it'll sit there until it starts to see guidance coming in from the Guardian. So right now, because the Raven is not putting out a signal, there's no effect of moving the Guardian around. And I'm going to use the Raven interface program to go ahead and turn on the Raven, and I've got it set so that about 10 seconds after the launch, it'll go ahead and send out a latched signal after that, just for demonstrating how this works. So let me go ahead and get the system set up here. Just kind of let everything get booted up. Now here I enter the flight mode test, and now I can go ahead and simulate the motor ignition. So if everything goes well, about 10 seconds after I go ahead and launch on here, the Guardian will start to be enabled to go ahead and operate the servos. So let me go ahead and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's pretty good. So normally this thing would just be mounted level in the rocket like that, and so if it starts yawing off in one direction, the canards will be set up so as to work in the opposite direction and hopefully bring the rocket back level. I'm only showing one servo on here. There's actually would be 2 pairs, so there would be also something that would be controlling in this direction, but not in the roll direction. And I just think what's sort of remarkable about the whole thing is just how simple the whole system is, and so I feel like I got the electronics done, and now I'm just working on mounting it all up in a section airframe and looking forward to testing it a few months down the line.